Hi guys, and welcome to another Micro Monday. So today we're going to be talking about bacteria and how they move from place to place. Bacteria are a type of microorganism that can be found absolutely everywhere. So they can be found in the soil up your garden, they can be found inside the food that you eat, and they can even be found all over and inside your body. So some bacteria can be useful, whether that be in our own bodies or in biotechnological processes that we've made them helpful for, or they can be a type of bacteria which is called pathogenic. Now this means that they can make us feel very unwell. So for bacteria to find themselves a new home, they of course have to move around. Now some bacteria can move on their own, and those kind of bacteria are called motile bacteria. But most bacteria have to use something else to get there, which is also known as a vector. So this vector that they use to get from point A to point B can be either an inanimate object, which can also be known as a fomite, so for example a wooden spoon or a pen, or they can also move from place to place using an organism such as an animal or our very own fingers. So there are loads of examples in which bacteria can move from place to place. For example, maybe you could have just made some sandwiches on a kitchen worktop that had bacteria on it, and now that's moved from the worktop to wherever the sandwich is. Or perhaps you've just prepared some chicken on a different surface and then left that without cleaning it properly, and then used that surface to maybe wash up some dishes, which means that there's the potential for the bacteria to go from that surface onto the dishes. But what if the bacteria actually want to stay put? What if they want to stay where they are? Whether that be because of an excess of food or nutrients, or whether that be because of the light or they're in lack of in that area, or possibly because there's an excess of moisture. In which case then the bacteria can do certain things to keep them stuck to that surface. Some bacteria use a concept called quorum sensing. Now this is quite an advanced concept where bacteria begin to secrete some special chemicals. And what this does is this helps the bacteria to talk to one another. And when they talk to one another, what they can tell each other to do is to sort of let out a very jelly-like substance around the outside of their outer membrane. This therefore means that the bacteria have created for themselves a jelly-like outer surface which they can use to anchor themselves to wherever they are. So a really good example for how these extracellular gel matrices work, which is the sort of jelly-like substance that the bacteria make to anchor themselves to the surface, a really good example can actually be done in the kitchen. So I'm going to hop over there and show you guys what happens. So as you can see here, I've got some water and some sticky jam. So as I'm wiping up the water, you can see that this comes off the surface quite easily, and that sort of represents the bacteria on their own, so if they don't make a biofilm. Now as I'm trying to wipe up the jam, you can see that it's a lot more difficult to remove from the surface, and this is because the bacteria will have made a sort of gel biofilm like layer to anchor themselves to the surface much more efficiently. So lots of types of bacteria use quorum sensing, and not necessarily just to help them stick to surfaces. A really good example of a bacteria that uses quorum sensing to make biofilms, which is a way of anchoring to surfaces, is called Pseudomonas Aeruginosa. And as you can see in the image below, that shows a piece of glass in which a group of Pseudomonas bacteria have sort of teamed up and grouped together and discussed with each other using these chemical processes that, right, we need to make a gel-like layer to stay stuck on this glass, and that's what they've done in the image below. So quorum sensing isn't just a technique used to help bacteria stick to surfaces, it can have other purposes too. So for example, a type of bacteria called Staphylococcus aureus, which is a type of bacteria that kind of lives on your body and on your hair, they can actually cause infection if too many of those bacteria get in, like an abrasion or a cut on your skin. and that's usually treated using antibiotics. But unfortunately, something that has come about in these bacteria is something called antibiotic resistance, which is where the bacteria are resistant to these medical treatments. And a way in which they can become resistant to antibiotics is by sort of discussing with each other using this quorum sensing technique. And a really cool way that bacteria can use quorum sensing is for bioluminescence. So a type of bacteria called Vibrio fischeri live inside a type of squid. Now when this squid is faced with a dangerous situation or moves around in a certain way, what that does is it gives the bacteria a signal to use its bioluminescence. And what that does is that actually makes the squid glow underwater in the dark. So thanks for joining me today, folks. I've had a really good time talking to you guys about bacterial transfer. This was actually my specialisation at university, so when I was studying my microbiology degree, this was what my final honours project was based upon, was the transfer of bacteria from different surfaces. So I've really enjoyed talking about this today, so thank you for joining me. Don't forget to check out our Twitter and our website, and I will see you guys next week for another Micro Monday. Bye!